So if you guys have any questions regarding with chapter 5.3 and 5.4, you can ask me now. Otherwise, we just go over your homework questions. Anyone have any questions on 5.3, 5.4 here? 5.3 question 10, okay. Okay, let me show my screen here. All right, so let's take a look at 5.3 question 10. So this is about properties of log. So there are a lot of properties of log. Let me show it to you. First, we got change of base formula. So change of base formula is used if you have a different base. So this is used a lot for calculators because calculator doesn't have base 3, log base 3, log base 4. The calculator only have log or ln. So in this case, you can change base. If I want to find like this case, like number 1, if I want to change log 1 over 5x, then we just use log x over log 1/5. X is the one for the argument. 1/5 in this case is for the base here. So this is how we do change of base. This is used a lot using because of your calculator doesn't have log base 1/5. So this is called a change of base. The next then we got 3 properties of log. The first property is called multiplication. So when you do u times v, is actually you expand it to u plus v. If you have a u divided by v is log u minus log v, and then you have log xn. This is very important property. They call it power property. This n you can bring it down, so become n log ax. So this is called the 3 properties of log. I want to point out to you that these properties of log can go both ways. So if you want to go from left to right, we are expanding it. And if you want to go from right to left, we are condensing it. Or sometimes we say right in a single log. So make sure you guys know which way we are doing. And you can, because it goes 2 ways here. And then a lot of students, when they look at this, oh, this one I can bring the n down. So every time when I see a power, I can bring my n down. No, you can only bring your power down as long as you put a log here. And all this log can change into ln, okay? And there's one note here, there is no property for plus. So please do not distribute that. So when you have log u plus v, don't distribute to log u plus log v. Because if you distribute it, you get it wrong. So I just want to point out to you guys that do not distribute your log, okay, to your question, to your work here. So let's take a look at question number, what question again? Number 10, okay, number 10 and 34. So this is question 10, log 272 times 47. You have to use the properties of log to simplify this. So how do we simplify this? So when you have a log 2 of 7 squared plus 4 to the power of plus times 4 to the power of 7. So for this question is you have to use a property log to rewrite and simplify. So what we do here is because this is multiply, so the log rule says that what happens when you multiply? Does anyone remember what happens when you multiply? When you multiply, you can actually split this up to become what? You can add it. So this, you will get log 2, 7 squared plus log 2, 4 to the power of 7. So this is the first thing we do is because it's multiply, so we can add it. And then what happens with the powers? Anyone remember what we do with the powers? We do with the powers. We can use the power property. What happens with powers? You can bring the powers up front. So in this case, your 2 can bring up front, your 7 can bring up front. So you will get 2 log 2 7 plus 7 log 2 4. So what I did here is the power that I have, the 2 and the 7, I bring it to that front. That is your power rule. And this is not your final answer yet because of him. Okay, because we can reduce log 2 4. We cannot reduce log 2 7, but we can reduce log 2 4. So can someone tell me here why we can reduce or simplify log 2 4 but not log 2 7? This is very important. This is your test. You will get this kind of question in the test. Why we can reduce log 2 4 but not log 2 7? Anyone know why?
Because
Not cancel out. If you remember when we do log, when you do log a to the power of log a, this is actually is 1. So if your base and your argument is the same, you will get 1. So in this case, we can simplify this. So what happened is that log 2, can you change 4 to base 2? Why I picked base 2 is because of this 2. Can you change the 4 to base 2? Yes, that is 2 to the power of 2. So what happens to the log 2 and 2? They will cancel out. They will cancel this one out. So what you get is just 2. So this whole thing, the reason why we cannot do log 2 7 is because 7 cannot change to 2. So the next one that we can do is log 2 4 is 2. So can someone tell me what is log 2 8 is? Anyone know what log 2 8 is? Can we change 8 to a power of 2? Log 2 to the power of 8 is a log 2. 8 is 2 to the power of what? 3, yes. So what is log 2 8 is? Log 2 8 in this case is 3. So that's why when you do log 2 8 is 3, log 2 4 is 2. Can someone tell me what is log 3 27 is? Log 3 27. No, you had to change the base, same base. So log 3 has the same base 3. 3 to the power of what is 27? 3. So what is log 27, 327? Your answer is 3. You guys with me here? Give you one more. Log 5 25. Anyone know what log 5 25 is? So change 25 to base 5. 25 is 5 to the power of what? Twenty-five is 5 to the power of 2. So your answer in this case is just 2. So make sure you guys know that if you got the base is 3 and your argument is 27, then you can change that. That's why log 2 7 is no good, because 7 you cannot change to base 2. Okay, so this will give us 2 log, oh, not canceling this, 2 log 2 7, 2 times log 2 7, plus what? 7 times 2, because log 2 4 is 2. So 7 times 2 give us 14. So your answer in this case is this one. Let's see if they accept it. If they don't accept it, you just change your base here. So this question 10, right? Let's see what we have here. Log 2 7. So this will give me okay, when you type this 2 log 2 7, Where's the log? I think it's under function or symbol. Oh, there you go. Log is right here. So log 2, 7, close of parentheses, plus 14. So this is, every time when you guys put the argument, has to be in parentheses. Let's see if they get mark it right or wrong. I don't know. Just waiting. So this is the answer you put in. 2 log 2, 7. Oh, it's correct. Yep. 10, right? Question 10. Yep, that is correct. All right. We'll do 5.2 first, and then we talk about 5.3. Okay, Anna. So 5.3. Sorry, 5.3 first, and sorry, 5.3 question 6. Sorry, you're in 5.3, and then 5.4. Question 6. Write this in a common ratio. This is exactly what we just did here in your notes. So how do you write log 3.015 in a common log? So which number is argument always? Yeah, your argument, the number is, it can be a number, it can be variable, it has to use parentheses. Yep, like here, you should use parentheses on that. So how do we write this in common log? So how do you write log 3.05 in common log? It's log 0.015 over by log 3. So when you do your common log, you take your argument, you put it on top, you put your base, put it on the bottom. So how do we do this question is, Anna? How do we do this question? How do you write this in a common log? Put in fractions. Log what? Symbol, that function. No base, just log. And now what should we put up here? 9 or 11? Yes. Put your parentheses, and then log 9. That's it. That's your answer. And then for natural log, you don't use log, you use ln. So you put fraction first. Where's my fraction? There you go. And then you do ln 11. Same thing. Can you do question 6 on the notes? Wait. Okay. ln 9. That's it. That's how you do this question. Okay. And now let me Chandra asked me 5.3 34. So I'm going to go 34 here. So this is how we write your log in your answer. Okay. This is how you log your natural log. This question did not ask us to evaluate. So a lot of students get wrong because once you use evaluate, then you use your calculator. You with me here, Anna? So once the question wants us to use evaluate, then you take out your calculator and push this button. But once they will just want you to rewrite, you do not need to do that. 34, question 34. Is that the last question almost? There you go. They want you to condense this. So when you condense it, you have to take the right side, become left side, and you go backwards. Usually we go number 1, number 2, number 3. Now you go to 3, 2, 1. So how do we condense this? Number 34, right? This is 1 to 1. How do we condense in? So first you move the 2 to the power. You move the 9 to the power. So you will have ln 7 to the power of 2. Stop showing up. And then minus ln z minus 8 to the power of 9. Okay, so I move the thing to the power. And then what do we do when you have delete? When you have subtraction. Anyone know what to do when you have subtraction? Subtraction means we have to do what? Divide. So in this case, you only need one. When you write in the condensed, when you have this, you only need to write 1. So this is ln. What is 7 square is? 7 square is 49 divided by z minus 8 to the power of 9. Everything under ln. So in this case, your answer will be something like what I just written down there. So ln and then you got a fraction, 49 on top, and then you do z minus 8 to the power of 8. 9, not 8, 9, sorry, not 8, 9. And this is your answer in this case. Okay. All right. So that's your answer right here. That's your answer. So let's talk about question 6 on my notes here. 5.3, question 6. This is question 6, right? Okay. So do not forget that when you have 1 over it, 1 over, this is back to fundamental of square root. Every time when you have a square root of x, square root of x can be written down as a power, and the power is 1/2. So when you have a square root of x, it's going to be x to the power of 1/2. If you have a cube root of x, this is x to the power of 1/3. So that so this is how we do the power. Make sure you guys know this. This is very important. One of the basic stuff is if you have a negative x to the power of -2, this is the same thing as 1 over x2. So you find out that when you have a negative, you put 1 over it. So if you have this case like question 6, this is 1 over square root of e. So in this case, that your e in this case is a power of -1/2. And as usual, ln e, because ln is a base 10. So if you see ln and e, they will cancel up. So that's why you get a -1/2 in this case. And now you got that? So what will be ln e? Let's say cube root of e. Anyone know what is ln cube root of e is? Anyone? Cube root of e? What is a cube root means? Power what? What is a cube root for power? Not 3. No, 3. Cube root is not the same thing as power 3. 3 is cube. What is cube root power is? 1/3. Yes. So this answer will be ln e to the power of 1/3. And what happens to my ln and my e? They will what? What happens to my ln and e? They will cancel. So your answer in this case is what? Just 1/3. That's your answer. Okay. So if you have ln cube root of e, your answer is 1/3. You guys all right here? Questions you have for this 5.3 here? Anyone have any questions for me before we do 5.4? All right. Number 9 on 5.3, homework or notes? Homework. Number 9. Number 9. Number 9. There you go. You evaluate this using change of base. So how do we use change of base for this? You can use log, you can use ln, doesn't matter for me. So how did we do question 9? How do we use change of base? Same thing as what we just did in question 6, but you have to use calculator to do this. So how will you do? Chandra, you asked me that question. How did we change this to log or ln? Log something, right? Log, what we put on top? Chandra, what's the argument? Yep, what is the argument? 0. No, that's not your argument. 0.155 will be your argument. over by log. And what is your base here? Your base is not 2, it's 2/3. They're on the base. So use your calculator to figure this one out. So you can use log of, where's my log? Oops, sorry. 0.155 log it divided by 2/3, right? 2/3, and you log it. Oh, no, this is not right. This is hard. Yeah, this is hard with using my take out your calculator because it's quicker that way. Log 0.01. Don't use this one. This is hard. Computer calculator is horrible. 155.155 divided by, in 3 decimal place, right? They want how many decimal place they need? 3. Log of 2/3. 4. How you get 49? 4.598. This is what I got. 0.155 over by log 2/3. I don't know how you get that. Make sure you watch your parentheses in this case. So it's 4.598. Class, if you doesn't know how to calculate this, you're having a tough time in the next session 5.4, I can tell you that. Okay. So we're gonna move on to 5.4 here. This is where we begin to solve equations. So we begin to solve exponents and log equations. So which is very, very important. Where was my homework here? All right. So let's talk about your work for 5.4 here first. So every time when you solve this equation, your answer, your equation can be exponents or your questions can be log. If this is for exponents, so if you have an exponent question, if you can make them the same base, then you make them the same base, then your power is equal. Otherwise, you can log both sides and then move your power down. Okay, so using what we call as inverse property. And then for log functions, if you have the same base, you can use the argument x equals to y. But what happens if they are different base? You move the base. Remember last time how we moved the base? You move the a to the side and it become power, and then you use that. But I want to point out to you, this is very important here, is every log functions that you have to check your answers. So every time when you do a log equations, you have to check your answer for extraneous solution. Okay, my picture looks weird now. I'm gonna unshare this because my picture is weird. This is what happens when I go online for too long. So we have to do the check your answer. How do you check your answer? It's very easy. Plug your answer back into the original equation, and if your answer came up to be negative or 0, you have to reject it. So what do I mean here is, let's say you plug in, you got your answer, and your answer is, gosh, what happens to my screen here? Let's say you got log x minus 3 plus log x equals to 5. For example, like this is an example. And let's say that you find out your answer is x is -4 and x is 2. So what do we do here is we can check your answer. So you plug -4 into here, and you notice this is already negative, so that this is extraneous. Extraneous means no good. Why this is no good? The reason why this is no good is because you get a negative answer. Okay. Then you plug 2 inside there. 2 minus 3 is negative answer. This is also extraneous. So this is also no good. So that means your answer in this case will be no solution. Your answer in this case will be no solution. Okay. You guys with me here? So this is how we, can you guys see my screen, or is that flickering like I have in my computer? I cannot even see anything now. That's no good. I see screen well. Okay, you guys see the screen well? Because my screen is like flickering right now. So that means this is no solution in this case. Okay, so let's take a look at your homework here. Oh my God, it's flickering like crazy. Anyone have any questions on your 5.4 homework? Or any questions that you have? Okay, no questions? We'll do some here. So like example is like question 4. Okay, this question 4, we can do what we call as make them the same base. How do I make them? How do I know I can make them the same base? Is because 1/2 I can change it to base 2. 8 I can change it to base 2. So if you want to do question 4 here, so what we do here is we change them to base. As you guys remember, 1/2 the power is negative. So for question number 4, this is not in the right mode here. So for question 4, that change of base, you make the base the same. So 2 in this case will be power of -1. So 2 to the power of -1 is going to be your 1/2. This is x equals to 2 to the power of 3, because your 8 is 2/3. So if you remember that they are power to the power, this is also power x. If you have power to the power, we can multiply this. So this is 2 to the power of -x. This is equals to 2 to the power of 3. So this is called power. Your base is the same. So once you get your base the same, your power also has to be the same. So your answer in this case will be 3. Okay. Now, this is how we do this answer, but there is also another way to do this, is you log both sides. So what you have in this question 4 here is you log both sides. And once you log both sides, you can bring the x down. So you will have x log 1/8, 1/2, and then equals to log 8. So don't forget you log both sides here. So so you will get this. Okay, so it's x log 1/2 equals to log 8. I log both sides of this question, and then my x bring it down. How do I solve for x here? Is I divide both sides by log 2. So x in this case will be log 8 divided by log 1/2. And if you do this in your calculator, you will also get 3. Okay. Oh no, -3. Sorry, you're correct. -3. Yep. No. Sorry about that. Your answer is -3. You guys good. So it's -3, not +3. Yep. Your answer is -3. Sorry about that. Your answer is correct. Okay. So I don't care which way you do. You can do it like this way or do it the other way that I showed to you. As long as your answer is correct, you don't do extraneous, because for this question, it's exponents. This is exponents, so you do not need to check for extraneous. For exceed, like okay, like question 4 is the exponents, you do not need to check. Question 5, question 6, question 7, these all questions you have to check your answer for extraneous, because it's a log or ln function or equation. Question 8, you do not need to check. Question 9, you do not need to check. See, these are all exponents. So when you look at exponents, you do not need to check your answer. But once you hit ln or log, like question 16, 17, 18, they all have log and ln, you have to check it. You got it for extraneous? So how do we do question number 5? This is easy. So how do we do ln questions here is you move your base. So what you do here is you move your base. Ln is base e. Don't forget, ln is base e. So what you do is you move the base. So x in this case will be e to the power of -6. And then you use your calculator to do this. So what is e to the power of -6 in your calculator? -6. Ugh, I hate my calculator. 6 negative ln. Oh, not ln, e. Hello. Where's my e? This one. Yep. Oh my god, this is really bad. I do not like really my calculator. -6. 0.002. Yep, that's the correct answer. Yep. So make sure you guys know how your calculator is much easier than my calculator. So so it's gonna be 0.0. Yep, that's your answer here. In 3 decimal place, 0.002 because it's not big enough. You guys okay with this? So it's easy for you guys to do if it's just, this is very simple to do this kind of questions. If what happens if you have log x like this? Does anyone know base is this? If you just get log x. Yes, this is base 10. So you just need to move the 10 over there. Okay. So this one, you just need to move the 5 over there. So you do 5 to the power of 1/2. Okay. So these are easy until you reach question 8. Question 8 is a little bit tough here. So so what we do in question 8? Oh, this is not tough because the base is the same. So for question 8, they all have same base. So what happens to the same base? The base is all cancel out. So what you get is x equals to x squared minus 2. So once you got them the same base like question 8, the base will cancel out. E and E will cancel out. So you just get your power. And what you do here is because this is a quadratic, you have to make this equal to 0. So I subtract x over on the other side. So 0 equals to x squared minus x minus 2. And you have to factor this. Okay. Why I didn't check your answer on for extraneous on question 5 is because this is a positive number. So when you plug 0.002 into your ln, it works. The only number that you plug in there doesn't work is the number 0 and any negative number. Then this is no good. Okay. So let's go back to this one. So next, once we cancel this, remove the x to that side, make it as a quadratic standard form. You have to factor this. Does anyone know what's a factor for x squared minus x minus 2? X with x. X what? Anyone? X not plus 2. You got a -1 here. Should be x minus 2 and x what? Plus 1. Yep. This is your factor in this case. And you make this equals to 0. So x in this case is 2. And x in this case is -1. And you do not need to check your answer here. It's because it's exponents. So see this exponent. So you do not need to check your answer. So your answer in this case is 2 and -1. So 2 comma negative 1. You guys all right here with this kind of questions? Next we have is like question 8, 9, and 10, 9, 10, and 11, and 12. All these questions and 13, all these questions and 14. So when you do this question, what is different between all these question 9, 10, 11, 12 is your exponent is not by itself. Okay. So once you get your exponent is not by itself, you have to isolate it. So that means that you have to get rid of this 5. And how do we get rid of this 5? You either add, subtract, multiply, or divide. So since this is 5 times, so we have to divide. So in this case, you have to do EX is equals to 89 divided by 5. So that is the first thing you do here is you have to change the EX because this 5 is multiplied to EX. This 5 has been multiplied to, it's like solving equation. So when you have this is like 5x. Imagine that you got 5x equals to 89. How do you guys solve for x? You divide by 5, right? So this is the same thing here. So when you get the 5ex, it's the same thing. You divide this by 5. So, and then how do we get rid of this e? You move the e down. So your x in this case will become log base e 89 over 5. But we know that log base e is the same thing as what? Log base e is the same thing as, anyone? No, not base 10. ln, yes, log base e is ln. So this is ln 89 over 5. And anyone has a calculator, can you help me with this? Yes, log base e is ln. So this is ln 89 over 5, 2.879. Yep, this is correct. So in 3 decimal place, 2.879. Okay. Then how do you do like question like number 10? How you do question number 10? Same thing. How do you solve 5x plus 6 equals to 37 first? Does anyone know how to solve 5x plus 6 equals to 37? What you do first? This is easy. You should know how to do question. This one. Subtract 6, and then what you do? Divided by 5. So this is the same thing. If I change this into power, you do the same thing. You subtract 6 and divided by 5, because that will get rid of your 6 and your 5. No, you cannot divide by 5. No, divide by 5 here, because it's 5. So you subtract 6 first. So you got 5 to the power of x, because there's a power here. It's 31, right? 37 minus 6 is 31. The reason why we cannot divide by 5 is because of the power is next to it. If it's been multiplied, like what we have in question 9, you have 5 times, yes, then we divide. But this one you cannot divide by 5. So what you do here is, in order for us to solve question 10, can you change 31, 5 to a same base? If you change it to the same base, we can do like number 8 or number 4 that we do early on. We change the base too. But unfortunately, 5 and 31 is prime, 5 is prime. You cannot change them the same base. So you begin to do what we call as log both sides. And once you log both sides, you can bring the x down. Remember last time we did it in question 4, that we log both sides, the x can bring down. So this is the type that we will do here. So you will get x log 5 equals to log 31. So how do we solve for x? We divide them. So log 31 divided by log 5. And then use your calculator and figure that one out. You guys with me here? So mostly, if you see exponents, if you see they are the same base, we can do that. We can do the same base formula. If they are different base, then you have to use log both sides and do the same thing. Does anyone know how to do question 11? What is the first thing you do here? 6 to the power of negative 4t equals to 0.3. Is your exponents, do you have anything around your exponents? Do you have anything around your exponents here? Like last time, we got 6. We have to get rid of 6. Last time, we have 5. We have to get rid of 5. Do we have everything around your exponents in this case? We don't. So how do we do this? We do exactly the same thing as what we did in question 10. Log both sides and then bring down the negative 4. So we have log both sides. So we log 6. And then you have the power. So the power, I bring it to the front. Negative 4t. And this is equals to log 0.3. Okay. And next, in order for me to get rid of t, I will divide negative 4 log 6. So this is kind of like negative 4 times t times log 6. So in order for me to get rid of all those so that t is by itself, so I will divide by negative 4 log. So log 0.3. This is the one that you guys have to take a calculator out and start punching it. Divided by negative 4 log 6. So I want you guys to go ahead, take your calculator out and divide this one out for me and see what you guys got. What do you guys got? This is very important, and this is where a lot of students make mistakes in my test. What do you guys got here when you do this? Yep, you get 0.102, right? Okay, you get 0.102. This is wrong. Now, if you put 0.102 inside your answer here, it's wrong. Can anyone here tell me why this is the one I tell you right now, the test that you take, a lot of students will do this and then they will get it wrong. Now, everything is correct except, anyone here know why this is wrong? Yeah, this is wrong. The reason why you get wrong is because if you look at this, your calculator will follow orders of operation. They will divide by negative 4 first and then multiply by log 6. But if you look at this, we should not do this. You should divide, you should multiply first, then divide. So what you need to do here is you need to have an extra parenthesis around. So can someone use your calculator and put an extra parenthesis around the negative 4? So that's why you guys need to do all this work. And it's important. That's why a lot of students get wrong. Your answer is no longer 0.102. Your answer should be 0.1. Anyone? One what? 168. Yes. This is the correct answer you need to do. So that's the reason why that a lot of students make mistake on the test and your online homework. It's not because you don't understand it, it's because you didn't use your calculator correctly. So your answer in this case should be 0.168. Questions so far with this? Again, class, all we're doing is all exponents. So that's the reason why that we do not need to check for extra nears. So question 12, can someone, let's do more difficult. 13, can someone tell me how you do question number 13 here? Negative 13 plus 3ex equals to 15. What is the first step you need to do? add 13. So you come 3ex is 15 plus 13, right? Which is 28, right? What's next you have to do after you add 13? Is your exponent by itself? No, the exponent is not by itself. So how do we get rid of that 3? You will have to divide it by 3 here. So when you divide by 3, then your exponent is no longer exists. Okay, so how do you solve this? If you get ex equals to 28 divided by 3, you don't divide first, you do it in your calculator on. So how do we get rid of e? You move the e over. Do you know what happens when you move your e over? Once you move your base e over to that side, that become what? You want to remember? When you move the e over to that side, it becomes something. What's the opposite of exponents? What's the opposite of exponents? You just do it in 5.5.2. ln, yes, when you move the e over, this is ln. So this is ln 28 over 3. Then you use your calculator. This one you can use, this one is not tough. You can use your calculator to do that. Okay. 14. How do we do question 14? 9.333? No, that is 28 over 3. You have to ln it. Chandra, you have to ln the whole thing. The answer is not 9.323. You have to ln 9.3. Is that 2.22? I do not know. All right, you need calculator. Yep, 2.233. Yeah. Yep. And class, make sure you use 28 over 3. Make sure you use 28 over 3, not 9.333 because of rounding. So this should be the, yes, ln, yes, that is correct, Chandra. If you use ln 9.333, you will probably get a little bit off because your answer, you round it. Okay. How do we do question 14? This one, icky one. What do we do first? This is your exponents is inside your parentheses. So how do we get rid of all those? So distribute 6. Do not distribute 6. No, you do not distribute 6. If you distribute 6, all wrong. Subtract 11 and then divide it by 6. Yes, so that's what you do here is 3 to the power of 6 minus 4x is equals to 41. You have to subtract 11 and then after that divide by 6. So what is 41 subtract 11 then divide by 6? What do you get? This is the same thing as 5. 41 minus 11 is 30. 30 subtract divide by 6 is 5. So this you will get 5 in this case. That is the first step to do. Do not distribute. We never distribute when you solve this. We never distribute anything at all in this 5.4. Next, how do we get rid of this power? We log both sides. So when you log both sides, you will have to bring down your power. So 6 minus 4x log 3 is equal to log 5. So I log both sides. And once I log both sides, I can bring the power down. Now, this is special. So how do we get rid of this? So how do we solve this is first get rid of log 3. And how do we get rid of log 3 is we divide this by log 3. So this, because it's been multiplied, so we'll divide this. And then next, this is like solving equation now. How do we get rid of 6? Inside here, so x is by itself. So we will be subtracting 6. So this is gone. And how do we get rid of that -4? We will be dividing this with -4. So that's how we solve this. Is x in this case is log 5 over log 3. And then whatever answer that you get in your calculator, you have to subtract 6 or -6. And then whatever answer you get, you will have to divide this by -4. So go ahead, use your calculator, figure this one out. Log 5 divided by log 3, and then you have to subtract -6, and then -4, divide by -4. So it's log 5 divided by log 3, and then -6, and then divided by -4. So you get 1.1384. It should be 1.134. No, I get 337. Yep. Make sure you guys know that this is, I got 7 in the back. You have to round. So this one you will get 1.134. That's the reason why you use the ANS button. You see my calculator, I use my ANS button. So that's the reason why it's accurate. Because if you put log 5 over log 3 and you start to round them, or I'm lazy to type 1.46 something, that's log 5, log 3 is 1.6 something, right? If you start to round this, everything underneath is all going to be wrong. That's why, Chandra, you get a wrong answer here. All right, 15. 15 is kind of similar to your notes. So that is kind of like question, oh, it's not in there. Oh, okay. So how do we do question number 15 here? Is substitution. So in order for us to do 15, you change all the e to the power of x to become a, that's it. So what happens when you have e to the power of 2x? So I just square both sides. That's why I get the 2x. So once you square both sides, you will get a squared. So this question number 15, it becomes a squared minus 7a plus 10 equals to 0. So it is a quadratic type equation, number 15, where I replace all my ex to become a. So in this case, you can factor it. So what's a factor for this case? Anyone? This is all easy factor. 10, what times what is 10? What times what is 10? Factor for this? -2 and -5, that is correct. And then you move, then you solve for a. So a in this case is 2, and a in this case is 5. But we are not solving for a here, we are solving for x. So you replace it back. Since we know all the a is e to the power of x, so now you replace your a to become e to the power of x. So you have two answers here. And now how do you get rid of this e? So x is by itself. We move the e down. So do you know what happens when you move the e across to the other side? What you will get when you move the e across to the other side? You should know this, we just did it. When you move the e over, like what we did last time, what happens when you move the e over? You get ln. So in this case, this is ln2. And then the next, use your calculator. And then the other one, it'll be ln5. Because one is 2, ln2 and ln5. So use your calculator, and then that will be your answer in this case. Okay. So far, everything we did here is all exponents. So now we're gonna do log. So like 16 is easy. Why I say it's easy is you just move the ln over. Do you know what happens when you move your ln over to that side? Opposite of ln is what? You get e. So you will get e to the power of -1. And then use your calculator to figure out what's e to the -1. And you get your answer. And make sure that you check your answer once you finish getting your answer. Anyone got what e to the power of -1 is? E to the power of -1. 0.368. And this answer will check. The reason why the answer is checked here is because your argument is positive. So this is checked because the answer is positive. Okay. 5.3, how do you know which log root? Depends on the question. If you have multiply, you use addition. If it's divide, you use subtraction. Depends on the questions. I do not. You will see some of them in this part. Okay. Same thing happens to 17. So what we do in 17 is we move the ln over to that side. So when you move the ln, it becomes e, but this time is not x, this time is 4x. So you will get e to the power of 1.1. So first you figure out what is e to the power of 1.1 first, and then after that, once you get your answer, you divide it by 4. The reason why you divide by 4 is because you have the 4x over there. Okay. So whatever you get again, make sure you guys, and then make sure you check your answer, and make sure that this answer also has to be what? Positive. What happens if it's negative or 0? It's extraneous. How about 18? Does anyone know what happens when you move the log over? What base is log when you move over there? Anyone, when you move the log, what base you get? 10. Yep. So this is going to be 10 to the power of 2. So you move the 10 over there and the 2 become power. So 10's power 2 is 100. And then you divide this by 5 because we got 5z. So this is, so z in this case is going to be just what? 20. And this is going to be checked because your answer is positive. Okay. So once you get a negative answer, you'll be no good. How about 19? Now 19 is the same thing as what we did before on exponents. You want to make the ln by itself. So this is like solving 4 minus 5x equals 11. Do you guys know how to solve 4 minus 5x equals 11? What do you do first when you solve 4 minus 5x equals 11? You have to subtract 4 and then divided by what? -5, right? So this is the same thing happens if you have an ln here. So when you have ln, we do the same thing. We subtract 4 and we divide it by 5. So your 4, 5 here will be canceled. This will be canceled. So what we have in this case is ln x. 11 minus 4 is -7. -7 over -5 is 7/5. And again, what happens when you move the ln over there? The ln will become what? E to the power of 7/5. And then you will get your answer in this case. So mostly they are pretty much straightforward type. until you reach number 21. So what is the difference between 21, 22, 23 that we have down here compared to 20, 19, 18, 17 that we have on top? So what is the difference between these questions and those questions? Anyone? This is very important. This is where a lot of students, if you only have, so the difference here is 21, 22, 23, so on, has multiple logs, or ln. But the one above it, 16 till 20, you only get what? 1 log or ln. So if you look at the question above here, 16, they only have 1 ln or 1 log inside the equation. But for 21 onwards, there are multiples log and ln. So what happens when you have multiple ln's? You have to condense it. What's the meaning of condense? Means you make it as 1 log. So that means you have to move the right side to the left side. This is called condense into 1 log. Okay. So that's why, Chandra, when you ask me when do you use, it depends on the question. If a question wants us to condense, you have to condense into 1 log. If a question wants us to expand, you will have to expand it. Expand means you go from left to right. Condense means you go right to left. So I don't know what the question wants you to do. So you have to read the question very carefully. So for this one, we have to condense it. So like 21 here. So what we do here in 21 here is you have to condense. This is 1 ln, which is fine. But for the other case, it's 2 ln. So we have to condense this. So how do we condense the right-hand side here? If you have 2 ln, you look at the sign. If it's a plus, we're going to multiply your arguments. If it's a subtract, we're going to divide. So in this case, we have to divide your argument. X minus 6 over by x plus 6. So this is what we do in this kind of questions. If you have a multiple, you have to condense it. Once you condense it into 1 ln, then the ln will be removed. So once you condense it, your ln will be removed. So you get x plus 7 equals to x minus 6 divided by x plus 6. So this is kind of like solving equations here, proportion. So what we do here is I multiply both sides by x plus 6. So I get x plus 7 times with x, because I don't like fraction. So I multiply x plus 6 to both sides. And the other side, the x plus 6 will cancel. So I just get x minus 6. So what you need to do here now is you have to FOIL the x plus 7 and x plus 6, which will give you x squared plus 13x plus 42. And then you have to subtract x and add 6. So this is equal to 0. So this is kind of back to your the quadratic equation here, where you begin to do foiling and then make it as a standard form equals to 0, and then you factor, put in a standard form, x squared plus 12x, 42 plus 6 is 48. And then this is all equals to 0, and then you have to factor this fellow. The factor in this case is x plus something and x plus something, right? So anyone know what is this going to be? X plus when you factor this. 48 is what times what? You need to get 12. Why? What cancel? Oh, because they are the same. So this is the rule here. If you have the same log, they will cancel. Must be both sides. So if you have if they have a same base, you find out that they will cancel it out. So what you left is x and y. Okay. So that's the reason why that ln x and equals to ln y, they all will the ln will cancel. So you get x and y. So that's why it is one of the properties says that. So that's why the ln here will be canceled here because they are the same. This will be canceled. And you can only cancel this if you only get ln and ln. That means only 1 and 1. You cannot cancel it. Oh, ln, I can cancel, I can cancel, I can cancel. No. So a lot of students do that in the test. Is that, oh, David said you can cancel all the ln. So I cancel all the ln. So what I get is x plus 7, x minus 6, minus x plus 6. You get everything wrong. So you can only start to cancel it if you put them in when you condense it into single log. Okay, so that's why your ln is canceled here. So can someone tell me what times what is 48? So you can get 12 when you add them up. Factoring. 16 and 4. 16 times 4. 16 times 4 is not 48. 16 times 3 is 48. No, 16 times 3 is 48, not 16 times 4. 48. Anyone? Not 16 and 4. 48. 16 and 3 doesn't work. Looks like this one you have to use 48, 6, 3, 8, 6. Nope, 8, 6 won't work. We have 8, 6. What else in the factor for that? 8, 6, 4. Nope, that doesn't work. 4 and 12. So you have to use quadratic in this case. Icky. All right. Yep, you have to use a quadratic in this case. So cannot factor. So we have to use quadratic formula. So x in this case is negative 12 plus minus square root of b squared. B squared is 12 squared, which is 144, minus 4 times a, which is 1, we can ignore it, times 48, 1 times. And then all over by 2, because 2 times 1 is 2. So what is negative 144 minus 4 times 48? This is negative 48. So x in this case is negative 12 plus minus square root of negative 48 divided by 2. So do you know what happens when you have a square root of a negative answer? Do you guys know what happens when you have a square of negative answer? You get I. Yes, you get imaginary. So, so in this case, this question will be no solution. Why this is no solution here is because your answer is when you do your answer, you got I is going to be imaginary in this case. This is correction. Yep. Okay. Yep. So we don't change it to I form. Once we know this is negative, no solution. Done. Okay. 22 is super easy. Why I said 22 is super easy is because they already have in a single log and they're the same. So question 22, you can just simply what? Cancel those two log out. So question 22, you will just get 3x plus 4 is equals to x minus 10. And then solve it. This is very easy to solve. Okay. 22 is easy because we got log and log. But 23 is a little bit different because now you got double log here. So can someone tell me what you do when you have double log? You have to condense this into one log. So what do we have here? Addition or subtraction? So this is addition here. See this addition? So if it's addition, we have to do what? We have to divide, we have to multiply, right? So x times x plus 7. And then this is equals to log 5 x plus 27. So yes, you have to multiply this. And now you get into the same log 5. So the log 5 will cancel. So this log 5 will cancel because they have both log 5 on both sides. So what we have in this case, you will get this. You have to FOIL this one out, distribute. So x squared plus 7x. And then I subtract the x from the other side. And 27, and then this is equal to 0. So what you do here is you will be, again, quadratic here. So make it in a standard form, x squared plus 6x minus 27, and then you have to factor this fellow up. I think this one you can factor. Yeah, this one can be factored. Can someone tell me 27 is what times what? This one has extraneous. That's why we're going to go through this. It has extraneous. So it's going to be a positive 9 and a negative 3. Yep. So negative 3 will give 9 and 3, positive 9 and 9 3 will give us 6. So x in this case will be what? If you solve it, x is negative 9, and x in this case is positive 3, right? Now you check your answer. So how do we check your answer is plug this negative 9 into your equation here. And you can tell that when you plug negative 9, this becomes negative. So this is extraneous. So that means this answer is no good. So this is how we check your answer. It's very easy. Plug what answer you have into your equation. If your argument becomes negative or 0, it's extraneous. If it's positive, it's good. Now plug 3 inside here. Okay, if this 3 is working. 3 plus 7 is 10, is positive. 3 plus 27 is 30, is positive. That means your answer in this case is just 3. So when you put this answer, don't put negative 9 because it's extraneous. Your answer in this case is 3 in this case. So this is how we do this kind of questions for log. So make sure you guys understand to make them as a single log before you can cancel your log. If you don't have a single log, no good. Okay. For the last few questions, please look at my notes because my notes have, I will talk about your test. My notes will have some problems here. So make sure you do the test, your problems here in this case. So next question we talk about is your test. So some students ask me about your test here. So your test 3, which will cover chapter 5 and 9.1. So is it 9.1 or 10.1? There's only one section left in chapter 9 or 10. Let me see, what was that? Not 9.1. Yep. So in this case, when you guys test 3 will be chapter 5. 5 will go 5.1 till 5.5. So 5.1 will go 5.1 to 5.5, and then 9.1. So you got 6 sections here. This test 3 will be given on Tuesday, May 5 at noon. And you got 24 hours to do it. Same thing as your test 2. I haven't set up your test yet. It probably will have around like 10, 11 questions, around, let's say 10 to 12 questions. Okay. So you will have around 10 to 12 questions in your test 3. It will be 5.1 till 5.5 and 9.1. Tuesday, May 5th. And then finals. Finals will be on Monday, May 11th. So 2 Mondays from now, that is your finals. It will cover everything that you learned, chapter 2, chapter 3, chapter 4, chapter 5, and 9.1. So everything, so it's comprehensive, means everything that you learned from the first day of class. You will be having around 15 questions of that, around 15 questions. Again, I haven't set your test yet. So that will be your finals on May 11, Monday, May 11. This week, we will do 5.5. So this is the last week. So 5.5 and 9.1 is the one that you have to do for this week. So that's the last two steps. So you got 4 sections left, 2 sections left. 2 for that is last week, and then which is this one we just talked about, 5.3 and 5.4. And then you got 5.5 and 9.1 that is due on the next week. So so we will talk these 2 sections. 5.5 is all word problems. I just want to point out to you, 5.5 is all word problem. So you might need to take a little bit more time to do it. That means you have a word problem in your test 3. And then 9.1 is usually is easy, is back to elimination and substitution. This is what you did in 980, your algebra class, how we got 2 equations. We used elimination and substitution to solve x and y. But this time, last time we used that chapter 9.1, it's going to be 2 straight lines. So that's why you intersect at 1 point. But for chapter 9.1 here, you don't have a straight line. It's going to be a parabola and a straight line. So if you have a parabola and a straight line, let me show to you what it looks like. So sometimes it can be a parabola and a straight line. So if you have a parabola and straight lines, you can have this. So this is a parabola, this is a straight line. The straight line can intercept at 2 points, so that means you got 2 answers. You can also intercept at 1 point, which is 1 answer, or no solution, means it never intercept at all. So you can have, so in 9.1, we're talking about what we call as nonlinear equations, where it can be a circle and a parabola. So if you have a circle and a parabola, then you can intercept up to 4 points. So you can up to 4 points here, or it can be 3 points. So you look something like this. So you got 1, 2, and then 3 over here. Or it can intercept at 2 points, these 2. Or it can intercept at 1 point, like this. Or it can intercept no point. So that's the reason why that when you do this kind of questions, last time you just find x and you plug in y and you got 1x, 1y answer. This time you can have a multiple x and multiple y answers. That is 9.1. So that is not that tough actually. So it's the same thing as what you guys did in elimination substitution. You just have multiple answers in this case. So so that will be your, I will post the notes and everything in your D2L and your videos. So so anyone, before I end this Zoom session, does anyone have any questions here? If you have questions, you can stay back. I can answer your questions. Otherwise, you can email me and let me know. All right. So I'm going to stop sharing here and I'm going to stop recording.